Hi and welcome to Maths class. In this video we're going to learn to find the distance between 2 points. And we're going to start with a pretty easy example, but eventually we'll be working towards finding a formula that can help us to always find the distance between 2 points, regardless of whether we have a coordinate plane and a grid. But in this case, you can see it, right? There's A at the point 1, 3, and there's B at the point 4, 3. And I've just moved from A to B, I've gone across 1, 2, 3. Nice and easy. So distance equals 3. No more to be done. And in this example, I've got something similar. A and B are on a vertical line with each other. So all I need to do is count squares, and we already counted these squares in the previous video. I've got 1, 2, 3, 4, 5, 6. So the distance between them is 6. No working out required to be shown, no work required to be done. Pretty easy so far. Okay, now A and B are not vertically or horizontally aligned, so I need a new method. And what I'm going to do, let's look. This is the line I'm looking for. Now, I'm hoping that you can see that this line is the hypotenuse of a right-angled triangle. And the good news is that in Year 9, we have already learnt a technique for calculating the hypotenuse of a right-angled triangle. So first of all, let's work out what this base is and what the height is, right? So I'm going to do that by counting squares. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 up here. Whoops. Try that again. That's 8 along here. Vertically, I've got 4. So at this stage, I'm going to use Pythagoras' theorem. Let's just call this C to make it easier for us. And I know that A squared plus B squared equals C squared. So that gives me 8 squared plus 4 squared is going to give me C squared. 8 squared is 64 plus 16 is C squared. And so that gives me 80 equals C squared. So C is the square root of 80. Now, what this question didn't say was whether I was looking at decimal places or whether I was looking at an exact value. So let's assume that we need to calculate this to a certain number of decimal places. I'm just going to grab my calculator. So I worked out that it's 8.944. And because that's rounded, instead of writing equals here, I'm going to change that to approximately equals to, which shows in my working that this is an exact value, but this is an approximate one that's been rounded. So let's look at what we did here. We used a right-angled triangle, and I just counted squares, but I want to point out to you that this 8 here is effectively the run as I move from A to B. And this 4 is basically the rise. So that kind of gives me this equation. The C that I'm looking for is the run squared plus the rise squared. Let's think about that as we move to our next example. I've got to find the distance between the 2 points shown. So even without drawing a triangle, I can see the point A is at -2, 1, and the point B is at 3, 2. So my run here is the distance, the horizontal distance. How do I find horizontal distance? I'm just going to go 3, oops, don't know why I did it up there, 3 minus -2, which is 5. Or I can count squares, 1, 2, 3, 4, 5. The rise, I'm going to do a subtraction again. It's 2 minus 1, easy, which is 1. Or I can count squares, and my rise is 1, nice and easy. So my distance then, squared, is going to be the square root of 5 squared plus, sorry, not square root yet. It's going to be 5 squared plus 1 squared, which is going to be 25 plus 1. So C squared is 26. C is the square root of 26. Grab my trusty calculator. I get 5.099. This is such a good example because what if I had to round this to 2 decimal places? Let's see what I would do. It cuts off here, which means that this 9 has to round up, and I should write that, but there's no number bigger than 9 that's a single digit number. So that would round up to a 10. So what I would do is carry the 1 in that 10 into this column, and it would actually be 5.10. The 9 has rounded up to a 10. Okay, that's how I would do that if I was rounding to 2 decimal places. It's a really good moment to just look at that. Okay, let's look at our next example. I need to find the distance between the 2 points shown. So once again, I'm going to do c squared is going to be the square root of, is going to be the run squared plus the rise squared. So the run from A to B, well, that's easy. It's 1 minus -2. It's 3 squared. And the rise from -3 up to 3 is 6 squared. So that gives me 9 plus 36, which is 45. C squared is 45, so C is the square root of 45. Once again, I grab my trusty calculator, square root of 45, and I get 6.708. 6.708 to 3 decimal places. Okay, so we've got a formula going here now. When I need the distance between 2 points, what I'm going to do each time is first I'm going to square the run and the rise and add them together, and then I square root. So in fact, a shorter way of doing this would be to go straight to this. Because the beautiful thing about this is with your calculator, you can put all of this in one row. You don't need to actually show all this working. What I could simply have done here was, well, my run is I subtract the 2 x values, so that's 1 minus -2, plus my rise, I subtract the y values, so that's 3 minus -3. Be really careful subtracting those negatives. It's not 3 plus 3. Well, sorry, it's not 3 minus 3. It is 3 plus 3. It's not 3 minus 3. It's 3 minus -3. And that's why we like to practice early on the grid, because I can clearly see that the distance, the vertical distance is not 0, 3 minus 3. It's 6. And that's because I've gone down 3 and then I've gone down another 3. Now, you'll notice that I'm not being very fussy here about y1 and y2, and that's because I square it. So it doesn't really matter whether I get a negative answer. Strictly speaking, the rise here is actually -6. So what I should do, in fact, is write them like this. I should write in there -3, that's my second point, minus 3. Which gives me -6. But then when I square it, I'm going to get 36 anyway, so it doesn't make a difference. Okay, once I square it, all my negatives disappear. Okay, let's do one more, using again this c equals, I'm going to do the square root of the difference between the 2 x's, which is the run squared, and I add that to the difference between the 2 y's, which is the rise squared. So x1 is -3 and y1 is -2. x2 is 3 and y2 is -3. So let's do it properly. Square root of, it's a bit wonky, 3 minus -3 squared plus -3 minus -2. Right, now you could put that straight into your calculator just like that, hit enter, and now just write down your answer. That's perfectly acceptable. I'm not going to do that. I'm going to calculate this. This is 3 plus 3, which is 6 squared, so I get 36. This is negative 3 plus 2, so that's negative 1. Squared is 1, so it's the square root of 37. Put it into my calculator, and I get 6.083. And again, I'm using approximately equals to show that I have rounded off. Now, you might be thinking, do I need to do all that? Can't I just count squares? Yes, you can. Can't I just think what's the rise and what's the run? Yes, you can. Do I absolutely need to use this? No, you don't. Unless you don't have the grid, in which case it might make it easier, and unless you don't have whole numbers, in which case it also might make it easier. So here's the rule. This is the rule. Distance equals x2 minus x1 squared plus y2 minus y1 squared, all square rooted. But I like to think of it as the square root of the run squared plus the rise squared. But just remember that this is not the simplified rise and run that you might find when you're calculating gradient. So if your run, in the first example, our run was 8 and our rise was 4, I didn't simplify that to 2 and 1, right? I left it as 8 and 4 because otherwise the distance would be too short. So what we're going to do now, is you're going to do these calculations, pause it first, and then hit play to see how you went. So I'm going to do them as well. So I'm going to use the formula. The distance is going to equal the square root of, now what I like to do is label underneath my question. This is x1 and y1, and this is x2 and y2. It's not so critical with the distance formula, but it's good to keep in good habits. So that gives me 3 minus negative 3 squared plus 15 minus 5 squared, which gives me 6 squared plus 10 squared, which is 36 plus 100. So the square root of 136, grab my calculator, it approximately equals 11.66. Oh, it says to 3 decimal places, so 11.662. Second example, distance equals. Get into the habit of not just writing equals. If ever you write equals, you have to say what equals. It's distance that I'm finding here. Square root of 2 minus negative 1 is going to give me 3 squared. 6 minus 3 is going to give me another 3 squared, which is going to give me the square root of 18. That's 9 plus 9, which is 4.243. All right, and now there's just one more set of examples. The key difference here being, here we're looking to 3 decimal places. Here we need to give an exact answer. Do the same thing, hit pause, and then hit play to see how you went. So I've got 1 minus negative 2 squared plus 5 minus 6 squared, which gives me the square root of 3 squared plus negative 1 squared, which gives me root 10. And because it asks for an exact answer, I better make sure my examiner can read that because that's not legible. There we go, root 10. I'm going to leave that as my answer. I can't simplify that any further, and I'm not going to find any decimal places because then it wouldn't be exact. So I'm finished. One more example, distance equals square root of, and this one I'll do the quick way, negative 2 minus 3 gives me negative 5 squared. 7 minus negative 3 gives me positive 10 squared, which gives me the square root of 25 plus 100, which is square root of 125. Now this one I need to simplify because I can rewrite this as 5 root 5. Okay, you can stop there if you like, but if you want me to, I'll just briefly talk that through. Remember that 125 is the same as 25 times 5, which is the same as 5 squared times 5. So if I square root 125, then I'm also square rooting everything on the right-hand side, which I can then rewrite as the square root of 5 squared times the square root of 5. And this square root of 5 squared gives me 5 times root 5. Quick revision on surds there. Surds we did do at the start of the year, but it's one of those things that once you've learned it, you're expected to know it, and it's definitely applicable in this chapter, as is Pythagoras' theorem. Okay, that is the end of our video on finding the distance between 2 points.